It's Chris Kuzmal again, and we're going to be introducing the concept of the resolution principle in this lecture. And the next sequence of lectures will be on this. What we learned before was that there's two different concepts of things that you can prove and things that are entailed by a given set of premises. We talked about soundness being sort of representing that you don't go outside the bounds of what is entailed, completeness meaning that you cover everything that's entailed, and that the combination of the two means that what you can prove is exactly what is actually is true, as it were. And Fitch is a sound and complete system. You might reasonably ask, is there a proof system that is not sound but complete? And that is true. You just have a rule of inference that any legal logical sentence entails any other. That's going to allow you to prove anything. Now, that's not meaning that you'll get contradictions, right? And you could have a system that's not sound and not complete. That's super easy. You can just have only one rule, and that is that any given logical sentence entails its negation. And that's not, you're not going to be able to prove everything, but you're certainly going to be able to produce a contradiction. And you could have something that's sound but not complete. For example, having only the rule that a given logical sentence entails itself. Well, that's not, those aren't terribly interesting examples, but at least we know that they're out there. There's one interesting system that is sound and complete, but it's not what we call generatively complete. We'll get to exactly what that means down the road, but I wanted to introduce the term generatively complete, and you can think about what could that mean as we proceed. Now consider the following logical sentence. We have P and not P, and then we have another logical sentence that is P or Q and not P or Q, from which we can kind of recognize that entails Q. Another logical sentence, P or Q or R, and not P or Q or R. We can kind of see that entails Q or R. And another case where it's very similar, but now we've negated the Q in the second sentence, P or Q or R, and not P or not Q or R. And from that, we can kind of infer two different possible logical sentences in addition to what we already have, which would be Q or not Q or R, and P or not P or R. And so this sort of sets the stage, sets a pattern for a rule of inference that's related to the concept of resolution, which is what Chapter 5 is all about. And to use resolution, we have to first transform all of our logical sentences into something that resembles the form we see here. And so that way of what we might call preconditioning our logical sentences is something we call endo. And we'll see how to do this after we learn one rule of inference in this system. And that rule of inference is called the resolution principle. We'll talk about that in the next set of slides. And then we're going to learn how to do that preconditioning, which is called endo. Then we'll talk a little bit about generative completeness. And finally, we'll talk about unsatisfiability, which will actually be, I hope, a satisfying promise.